So the process is very competitive. We had a wonderful set of submissions from a range of exciting topics. But in the end, the jury managed to select 2 great proposals, which will definitely inspire great conversation and debate. And since the process is not anonymous, I excuse myself from the selection process, given that I know and have been affiliated with both our speakers, actually. Tomorrow, we have Dr. Meredith Ringel Morris, who will present Artificial General Intelligence is Coming. Is HCI Ready? And this afternoon, I have the honor to present Dr. Ivan Poupyrev, who is an award-winning scientist and inventor, active in many different research areas regarding sensors, AR, UbiComp, and haptics, and has led research at various companies like Google, Disney Imagineering, and Sony CSL. Ivan's work has been widely published in our community, including SIGGRAPH, CHI, UIST, and he has over 100 issued US patents. He's also widely recognized through prestigious awards, including the National Design Award for Interaction Design and the Cannes Lion Grand Prix Award. In 2017, he won the WIST Lasting Impact Award for his work at Sony CSL with his colleagues on tactile feedback. So very excited to hear this talk with the very humble title, The Ultimate Interface.
Thank you so much. Let's see if I can talk to both microphones. So I'm very excited to be here. I've been part of the WIST community for many, many years. I published a lot of papers here. You've been coming year after year, so it's really great honor for me to be here and talk to you this year again. It's also a great time to give vision talk, because about a few months ago, a group of us left Google, about 5 of us, and formed a new company called Archetype AI. So I don't have a PR department anymore, and I don't have a communication department who tell me what I can talk and cannot talk. So it's very useful to have for vision talks, to be able to talk about things you really want to talk about. So I will start, so today I would like to talk about future vision for interactive system design and development. It's a really boring start. And I would like to start really a little bit with the backstory. What's the story behind it? I think the fundamental problem we try to solve in this community is that designing interfaces is difficult because it's just not very natural to interact with computers, right? Probably out of all technologies we develop, this is the least intuitive and least kind of natural for us to use. We've been knowing this for many, many years. This is an example of a 1945 interface to control the radar. And you can see it kind of didn't change that much since then. It's kind of like the same components are still there. The way we interact with computers is dramatically different how we interact with the real life. For 6 million years of evolution, we've been learn how to use environment, the physical feedback, understanding what's happening. When you work with the analog devices, with the analog machines, it's predictable, it's understandable, learnable. This is very different from when I go from this to this, right? So this is not clear for the people. It's very difficult to understand. So a lot of work for us in the community was being focused on making interaction and interfaces more natural, right? So this has been working for many, many years. And a lot of breakthroughs in our area happen is kind of finding the ways to make interaction more natural. Starting with a desktop metaphor and graphical user interfaces by Xerox Spark, popularization of touch screens and bringing them to real life, like through the iPhone and mobile phones, was dramatic because it's removed another layer of interaction for the interactions. Really, really changed the way for how we use it. Voice interfaces we've been trying to use with different success, virtual reality, all these examples of how to make interaction a little bit less computer-based, a little bit more human-based, right? This is kind of transition we're trying to go to. And with a lot of success, right? So this community contributed a lot to those things, building the incredible work, incredible innovation to this stuff. Now, it's all great, but I think we're kind of reaching the fundamental limitation of what we can do in terms of moving what we invent into the real world applications. I spent most of my life in industry, and this is very clear and that there is 2 factors which stop us to moving innovation in HCI to the world and to the product. It's the deterministic nature of human-computer interaction and the manual design of interfaces. It's very laborious, very difficult, very boutique process to build interaction. It requires a lot of people and very, very expensive. But deterministic nature is one of the biggest problems. Let me explain what I mean by that. So when we think about interaction, we always think, okay, the user interacts with the computer. But the reality is that computer is just a medium. It's intermediate medium for designer to communicate their design to the user. And whatever the modern techniques designers use, it user-centered design or natural computing or natural interaction, fundamentally designers design this construct, and the user kind of has to go through this, and it's completely deterministic. Whatever designers decide, user has to do. And there is no freedom for the user to choose their path and choose whatever they want. So I was trying to think of the best analogy of what we're trying to build here as a community, and kind of like a maze for rats is kind of coming the best example. So we're building this kind of the maze for the rat. We're designers, and we're designing this amazing maze, and we put the user, and the user runs around the maze, and thinks has choice, but it doesn't, right? He doesn't. They don't have the choice. They have to run through this maze, and improving the maze, and adding maybe haptic feedback here, and maybe a little bit better interaction here, doesn't change the nature of the maze. It's still a maze, and it's a problem because users are not a mouse. Right? The users live in the physical world around them with a lot of things happening with a massive physical context around them, which does not get reflected in user interaction at all. Now, of course, there's a lot of research work in the context understanding, context interaction, but here we hit these basic limitations that designers who build these interfaces simply cannot take into account anything except for very few contextual elements from the interface. It is physically impossible. I once did exercise where I tried to calculate how many variations of interface the user need to discuss and kind of consider using just this list. Say for example, 5 emotional states, 10 unique interests, 5 physical characteristics. If you just compile that, the designer ends up with about millions and millions of variations of designs we need to be taken account for, right? So this is just not scalable. It's not going to work. So the question is like, what if we stop designing interfaces altogether? Just stop designing them. What if we can build a pre-trained AI foundation model, a single model that can understand the physical world and can generate interfaces in real time based on fluid user context by itself? Completely generative interfaces. And I'm not talking about this, like take a napkin, draw a website, and then create a website kind of nonsense, right? I'm talking about fully generative interfaces, which happens in the real time. So can we go from this situation to this situation, where the designer is gone, and there's a physical AI in the middle, a fully generative model, which understands what's happening, and all the interfaces generate in real time. And if we can do this, then interfaces could become non-deterministic, completely non-deterministic, completely defined by what people are doing, and will be purely generative. And that's kind of the crux of my vision talk, to be honest. This is pretty much what I wanted to kind of provoke this audience here. How can we build? Is it possible to do this? To forget about design interfaces, is it possible to do this? And how to do this? But let me give you some thought about some questions, some open questions, how to approach these things, and show some examples of these potentials which is possible to modern generative models. So how can we build this AI foundation model for physical world which allows to generate interfaces? What will be the step to do this? Let me go through some open ideas, right? So overall, first question is like, how can we enable rich multimodality in real time, right? So because if we talk about this kind of physical AI and interaction with the people in the physical world, understanding what people do requires a variety of sensors, right? So, these multimodal LLMs these days are very popular. Like just recently, a lot of wave of multimodals, ChatGPT Vision and Lava and a whole bunch of other things coming out. But most of them sort of has single modality. It's text plus one modality. Text to image, and it can describe what the image happens in the image. Or text plus video, a short video can describe what happens in the video. Like examples are here. And but this is not enough if you want to build interfaces. It has to be in real time, it has to be live. So it has to, at the first stage, it has to fuse a large number of sensors using Gen AI. So this is an example of video, how it could look like. We have 2 video streams, and then the generative AI model can understand what happens across both of them. The people jumping in the street, somebody delivers a package, and then you type a question. what happened. And then the model should go across both interfaces and figure out what's happening there, and then give you a short description of what happens on the course of the video. This is kind of working demos. Another example, but this is, so the current Gen AI models, they don't really do that, right? They kind of like focus on one modality and one thing. They don't do this multiple sensors. But what's more interesting is if you start combining multiple modalities together using Gen AI model to fuse them together. This is an example, for example, this is an example of video where the fridge is broken, makes strange noise. So the video, the Gen AI model combines noise from video and noise and video from noise from video and video itself to create a single experience. So let's. So it doesn't play sound for some reason. Anyway, so make a sound there and kind of noisy sound when the door is closed. When the door is open, it stops. When the door is closed, it makes a sound. You can see the sound wave going out. And so what's happening? You can ask the model. The model says in the video there's a refrigerator in the kitchen setting, and the refrigerator making noise and sounds like a violin, indicating that it might be faulty. At one point, the person appears in the video and opens the refrigerator door, and the noise stops when the refrigerator door is open. So it's interesting how the model is able to parse apart that there's a refrigerator making a noise, and be able to understand, because without noise and just by the video, it's not possible to see. And the noise without video is also impossible to understand. So fusing them together allows to generate the concrete response. So another questions another kind of challenge we have in this vision is, what if context of understanding is derived from the meaning of things happens in the world? So this is an example where we're using Gen AI for spatial localization using semantics. So instead of putting devices in the room, we're understanding where people are, and the model trying to figure out where things in the house. Let's see how it works. So as the model goes around, as video goes around the house, it looks at the objects around and predicts using Gen AI models, so it predicts where it is. It says there's a kitchen, a music room, because it see the devices. Or small music studio, small living room. So it generates localization where you are in a room purely by observing where you are versus trying to, the classic things, put the devices, understand where they are, use Bluetooth, and so on and so forth. This is another interesting experiment where where the video is, where the model looks at objects and trying to figure out where it is. And by changing an object, we can see what the model would react. So it's constantly trying to figure out what the context is from the meaning of the object it sees. It says there's a kitchen now. It always switches to the bathroom for some reason. Don't know why. And then it thinks, oh, but it's a botanical garden. It's an elegant living room. So the model can go through all those examples and try to generate the meaning of where you are located just by observing things. It also can observe people's actions. Or can see, there's a dining room, and so on and so forth. You can also use Gen AI to generate semantic context by using Gen AI. So like basically you're looking again at the world, combining these whole sensors, and trying to figure out the social context of what's happening in the room just by observing people's behavior. So this is an example of how Gen AI can refer meanings of what happens in this room. Someone's in the kitchen next to the refrigerator, is trying to understand that couples discussing food options in the kitchen, the family preparing meals in the busy kitchen, and so on and so forth. So we can see how using Gen AI models can generate the context, meaning of context, just by observing this happening in the kitchen. What's important here is the same model used across all these examples. The model was not pre-trained, the model was not fine-tuned. This model is generally understand all these functionalities with simple settings changes. My third question is that how can AI generate interfaces autonomously? And at this point, we talked about generating interfaces without help of designer. This is some early experiment how it can be done. Now, this is pretty annoying. So basically, it looks at the context and tries to immediately generate, kind of like almost hallucinate what kind of offers it can do, what kind of offer to you. It says like, we'd like to suggest to do with the furniture. We'd like to see some organizing your bedroom. We'd like some tips on creating a cozy sleeping environment. Is anyone sleeping in your bed? So it's continuously going kind of like and generating all these requests by observing the context. Now this is not, of course, we want to go to, but this is an example of how the context can be generated in real time. Now, this is another example. So what we need to do, of course, is to narrow the GenAI models when we go through these interactions and give them objectives. So this is an example where the GenAI the models, physical AI models, give an objective to follow and try to meet that objective by analyzing the environment. So here you're asking, can you alert me if you see any hazard? Again, the same model trying to summarize what it means having a hazard, create a vector of possible solutions. We're using pre-recorded video here. And there's a kid runs around and comes to the kitchen. There's a kitchen and the stove on the other side. Now, it misses a couple of times, but over the time, you start noticing the kid running around the kitchen. And it's going to say, like, okay, I see there's a little boy in the front of the room. Please supervise him or ensure his safety while cooking or baking. Now, this is very, very early work for generating this kind of like interactions. And, but it's already showing promise. And the interesting question is, like, what else can you do? How can you add visual components and visual feedback for that stuff? And the final questions I would like to ask is that if we try to build this vision of the completely generative interfaces without designing them by hand, should it be a single foundation model for the physical world? There should be multiple different models. What's the best way to approach it? And because if you have a physical AI model, kind of like being observing the world, and a single model which is doing this, what it can do, it can replace all other models with a single model. And that, I think, is the biggest, very important promise, because you can have a model which slowly learns about the world, and as you add additional use cases, it's becoming more and more powerful to understand what happens in the environment. And this is both attractive but also maybe dangerous, because if you build such a model, so that model will become an ultimate interface for us and computers. So thank you very much. That's kind of my talk.
Okay, so the UIST Visions program is intentional about lots of room for questions, so please come up to the microphones. And I'll maybe start us off with one question. Thank you, Ivan. It's very inspiring. I think it's really thought-provoking, like the level of like human-like reasoning that these models allow. But one thing that definitely comes up is interacting through text or language, obviously powerful. But on the other hand, it can, take us into like the hyper-reality where there's like a gazillion options and gazillion buttons and sliders in like AR environment or VR environment. So one question I have to you is, how do you take all this knowledge and create sort of like just the right amount of UI elements or interface that will match the task like really carefully, as you actually have done many times throughout your career?
It's a good question. I think this is one of the core questions of trying to use GenAI models for this kind of physical designs. I think there's a multiple hypothesis right now. One of them is basically objective-driven design of these models, where you train the model to follow certain objectives, right? The question is how to set up these objectives is a big question, right? Right now, people using text. We think that be able to understand human intent indirectly, because human intent is very, very descriptive when you do things. Combination of objective setting and human intent would probably allow us to narrow the models to what needs to be done for the user at the same time. But this is an open question, right? I think you should solve it.
I thought the AI was supposed to solve it.
Well, yeah, exactly. So the AI will solve it too. So so that's I think this sort of the human intent. We did a lot of work on human intent before, when I was working in all previous companies before. And indirect capturing of human intent, there's explicit intent and implicit intent, right? Combination of the two, I think, gives us opportunity to really understand what user needs without them providing as a little like conscious input to the system. We don't have to set up every single thing. Anyway, so that's sort of my thoughts.
All right, thank you. So we'll alternate left and right, and if you can just state your name and your affiliation, great. Thank you.
Hi, I'm Bala Kumaravel from Microsoft Research. So I have a couple of questions. I'll try to keep it short. First question, what form factor do you see for the ultimate interface for capturing data about a user? Are you thinking of an outside-in style data capture, where you have cameras and stuff embedded in an environment, or is it something that the user has, like a wearable camera and going around? Yeah.
So the question is, if I repeat the question is what sensors we would like to use for the capturing devices? I think there is as little as possible, right? So one of the kind of premises of this vision in general is that you could have a very sparse sensor modalities, and then an AI can fill the blanks, right? Similarly, how we do this with, like, has been demonstrated for the text, for the images, and so forth, for the interaction. People's behavior is not random. People's behavior is actually very predictable, and there's a lot of work that was in the UIST community, by the way, which showed how we can predict where people are at certain period of times, right? So the goal would be to have as little as possible, as a few sensors as possible, and then fill the blanks with that. And that could be mobile phone and your motion patterns, some form of then you have like kind of like customers, like not customers, sorry, like private citizen, people's like like consumers, and then you can have industrial use cases, right? So where the people work in certain environments. So industrial use case, you can instrument environment with specific sensors to make sure that certain things are followed. In public spaces, I think it's going to be mostly like something which people wear anyway, mobile phones and watches and stuff like that.
So a quick follow-up to that. Now with these sensors, right, one of the success of large models is the pure or vast amount of image and text data that has been available online to train these models. So with these newer forms of input modalities, how do you think the training might happen? Like, where would we source data from?
Right. So I think this is a good question. I think there is we think about when we were working on Solly back at Google, that was actually a problem we tried to solve, because you have a radar, a completely new sensor which nobody used before, and we need to capture a large amount of data. So there's three approaches to capture data, because interesting thing about sensor data is that sensor data can be completely simulated. All this radar is designed using CAD system and CAM systems, like electrical simulation systems. So simulation synthetic data for those sensors is going to be one of the key design approaches to build all these training models, because they can be simulated completely. Second one is going to be robotics. We actually build robotic farms when we build solely for Pixel 4, when we sell the gesture for the Pixel 4. We actually build a robotic farm where we basically repeated gestures we wanted to capture data with slight variations which run day in, day out, right? So it does take a bit of, so it's kind of not that expensive, and robotics is becoming cheaper and cheaper. And the third one, which is very important, is that it's been shown many times that instead of trying to capture a large amount of data, it's better to capture a small amount but very, very high quality of data. So setting up and capturing very, very high quality of data for specific use cases, I think will allow us to bring the performance of the model for this time series and real-time sensing data dramatically higher. So,
yeah, thank you very much.
Hey, Jackie Young from Stanford University. First of all, I want to say I like the idea of generative UI. Although me personally, I'm not convinced at all that there will be an ultimate interface that will be automatically generated by the model. Here's my thinking. I'm thinking, like, the way I think about it is almost like a proof. So first of all, the way we design UI so I want to say my proof, and I want to see what's your opinion on that. Maybe I'm totally wrong. But I think the idea of like why we have interface today, like why we have designer today, is that designers trying to basically solve a wicked problem, right? They have limited resources, sometimes limited CPU power, sometimes limited screen real estate, sometimes it's a handheld device, so the user is not super flexible. So they're trying to use limited resource to achieve a super great goal where you want user to be able to use your app, you want all sorts of different users to use your app. So these days, the way we achieve that is the designer has to work with human users to observe how they interact, to see what's their need, and then try to solve their need. And then if in the future, there will be an ultimate model that will be automatically generate great interfaces, then that model will have to first be able to simulate human user perfectly. And that basically means that we will have a model that achieves beyond AGI. And then if we actually reach that point, do we really need human user? That's a different question. So my personal take is without beyond human AGI, we cannot achieve ultimate interfaces. And then what's your thought on that?
I never said ultimate interface can be achieved. I just want to make it clear. This is sort of like the goal in the infinity, right? This ultimate interface. But the goal in there, I think we will achieve dramatic improvement in the way how we build interfaces, develop interfaces. I think these are good questions. I don't have the clear answer right now. I can share some of the thoughts about that. I do think that we start by building these generative interfaces in a narrow domain fields first. So I think the difference between building several large language models, right, is that until you actually build the whole model and actually make it running and kind of like showing to you, you can't really judge if it's good or bad, right? Because language is such a powerful concept, and you have to, we very quickly understand if something is natural or something is not natural, right? So to have this dramatic improvement towards towards kind of today's models requires a lot of data, a lot of work, and build a lot of stuff, and so on and so forth, right? I believe we can start building generative interfaces in very relatively narrow fields, where the amount of data and people's behavior are more or less understood. But the goal there is that it's going to be additive. So as we build one model, we instead of building another model within different modalities, we'll be adding that to the previous model. So slowly, this interface is going to be capturing more and more of the human activities and human needs and human factors. I also feel that when Xerox PARC designed graphical user interface, right, they made a couple of assumptions, right? And one of the assumptions that they made, which allowed to kind of them make a leap forward in terms of graphical user interfaces, is that the cost of the memory is going to go to zero, right? Because they went for the vector-based display to the pixel displays, right? And at that time, pixel bitmap display was super expensive, right? Because the memory was crazy expensive, real-time memory, right? But they made this bet that the memory is going to be free, next to free, cheap. And they designed the whole interface based around this assumption. That allows them to free them from the constraints of imagination of what can be done. I think in order for us to move forward in similar directions, we have to free ourselves of multiple constraints as well. We should assume that bandwidth is going to be free and computation is going to be free. So basically, all the data, all the sensing data you have, are going to be streamed to the central model, and the bandwidth is going to be free, and computation is going to be as much as you want. So, by doing these two assumptions, I think we can rapidly free ourselves from these limitations, like what needs to be designed, how to optimize it, and prematurely. So building these models, build these ideas toward this sort of ultimate interface. But that's kind of like my answer I can have at this point. Maybe in a year I'll tell you something more.
Cool. Yeah, I really like the idea of starting from specific areas. I think I definitely agree with that. And also kind of I personally think maybe the generative interface might be more useful for more expert user where they know what they want, and for novice user, I feel like user also learns from the interface a lot. And I'm a little bit hesitant whether the GPT or something can generate a good interface that the user can learn from the first try. And then from the limited experience, I actually do some generative interface with GPT, and my experience that if you ask GPT to generate certain kind of interface, it will contain all the element, but it will be super not user-friendly because it had never tested with the user before. But thanks a lot for the talk.
Thank you.
Hongguo, University of Michigan. I think it's related to the previous two questions, but you said that bandwidth will be free, compute will be free, but I think data is not free, and that seems to be the biggest challenge. The current GPT-4 vision model have mass amount of text and image data to be trained on. So for the examples that you showed, it seems like that kind of data is lacking. And in order to provide that value, you need to collect a lot of data first in order to train and provide a little bit of utility, and then you hopefully will encourage people to be able to continuously contribute data to bootstrap it over time. So what do you see you touch on the data collection part a bit, but what do you think about this question and about the long tail of collecting more and more data and the privacy considerations around that?
Well, I think there is no way around. We just need to collect this data, right? So I don't think at this point I have a magic answer for those questions. Again, I think focusing on the initial use cases, which allows us to kind of use a large variety of techniques for generating this data, either synthetic or robotics or by hand, collecting this data by hand. Yeah, I think this is a good question. It's one of the challenges we need to solve, if you want to move with these kind of directions forward.
Cool. So quick follow-up. Do you think we'll be able to achieve stronger AI by accumulating use case, or there should be like a bigger jump, you know? So is like solving small problems one by one the way towards that more generalized solution?
There is indirect proof that by teaching, building large models and then training the different tasks creates a transfer learning across multiple tasks, right? It's been shown in text generation, it's been shown in video, in images, and so on and so forth. So I only can hypothesize that the same would probably hold for the interaction and for the like real-time sensing data. I don't think why wouldn't that be the case. So when we talk about small cases, we're talking about training the model on additional adjacent use cases, and then we'll be able to see, do we have this transfer learning happening? But this is a really open question. Right now, so using large models for time series data is right now becoming quite a hot topic. We look at this very, very, very carefully and see how we can do this. So this is a really open research area where I think with the contribution from the community would be great to see, do we have this transfer learning or we don't have the transfer learning? How well the multiple streams of time series data can correlate to each other. So this is really open field, green field. Thanks.
Hi, this is Jun Shashin from University of Cambridge and University of Bristol. So my question is that, as AI, like now AI is like super centralized, like ChatGPT is all stays on the cloud. But as AI becomes more and more powerful and more personalized, like it basically have all our kind of personal informations. And if in the future we might have some like wearable devices that sees everything that we see, like basically shares our image. Do you think in the future AI be decentralized? For example, like every household in the world they have a AI hardware device, like AI server, like connected to the Wi-Fi router, and then instead of having the AI sitting on the cloud.
Hello? Yeah. Hello. Okay, here you go. I think this is really, again, so this is really open field. I can only say for what we see from talking to like a lot of, what I've seen talking to a lot of sort of people who are interested in this kind of generative AI and generative use case for the physical use cases. There's basically three approaches. One approach is people really would like to have all the AI centralized. So they don't want to deal with the housing and so on data. The way they dealing with managing their models, security, they just like want to be able to send the data and get inferences, that's all. Another kind of people are really careful about the data. So they want to have on-premise data, right? So they want to have the data on the device. A lot of people, times, like hospitals and people have a sensitive data, they don't want the data to leave the house. And so in this case, I think you would have sort of like cascading models of these models where some of the models are going to run locally and some models are going to run in the cloud, and they kind of form one kind of like continuous model. And the third one, use case, which actually comes quite often, a lot of people are interested in distillation, where you basically have the large models in the cloud, which can do a lot of things. And a particular device maker, a particular application kind of, customer or company, they would like to create a very small model which does subset of things, which runs just on their model without connecting to the device, to the main AI. But they would like to have an opportunity over the time to expand the functionality, to add model additions, but they don't want to retrain these models over and over again. So this is a kind of almost like subscription service where the small models come into your device from time to time and update you and becoming more powerful. So I think right now I see these three models right now being actively pursued across the industry. Maybe there's a new model, which one's going to win? We're just at the beginning of this kind of race. So we'll see what happens.
Thank you. Sorry, another small, quick question. It's about like you mentioned about the memory is free. I agree to a certain extent that for large language models, the memory is some like sort of free because we can have super long context windows for large language models, and there's a lot of research on that. But for multimodal language model, like multimodal foundation models, for example, especially like vision foundation models, it will be hard to believe that a model can consume like up to say 100 days of videos data, and then we do a visual query from the 100 days of data. There should be a kind of a vector database to store the data.
Exactly. So there's going to be I believe there's going to be ways to compress this data. And they're going to be either compression on the sensory side, where you compress the sensor data and using classic compression, or on semantic side, where the data is being transcribed in detailed way, and then you're compressing it in a semantic space as the time passing by. It's very interesting how close it's going to be to human memory, right? Because right now computers don't forget anything; it's just like always there. But it's like searching data becoming harder and harder. But people have a forgetting function, right? So it would be interesting to design these models when they start forgetting things over the time, right? So is it been valuable? I don't know, but it's kind of one of the approach we're thinking about is that how can we model the forgetfulness of those models over the time? And they do this by basically clumping this data in semantic space closer and closer together, right? So you're becoming more and more rough as you go forward. Because you can assume if people don't access this memory over the time, then it's become less and less valuable, right? So I think memory is actually a very interesting direction, and this is another topic which is actually very hotly debated right now in this area: how to build those memories, and how to manage them, particularly for large data like sensor data.
Yeah, it's also like a lot of people are now building like stronger models, but not too many people working on like making the model, making memory longer. I don't know, but thank you very much. Thank you. Yeah.
Okay, so we're running over, but I think that's the whole point of this this point of the program. I think we can go a little bit longer, but if you can do brief questions, then maybe we'll get to Benko.
All right. Well, now I'm incentivized to talk for longer.
Benko's a bookend.
Yeah. So Jeff Nichols from Apple. First of all, I just want to say I don't know if you've seen Person of Interest, the television show, but those demos are kind of making that show come to life in a very particular way. But what I really wanted to ask about, though, is kind of, so I felt like a lot of what you talked about, and I'm super into this idea of generative AI, I think, or generative UI, I should say, something I think I've thought about a lot. But what I felt like from kind of your description was I saw a lot of sensing in that, but I didn't necessarily see a lot of interaction, and I feel like that's I think that's an additional challenge beyond even what you showed, because I think, we need to have some way of modeling interactions, of having the models be able to think and reason about like what is an efficient interaction for any particular kind of task they might be trying to do. And actually I think that's an even harder problem than I think some of the things you talked about, right? I mean, there's a reason like Walmart and McDonald's become these huge companies because they figure out some processes that happen to work particularly well, whereas plenty of their competitors did not. So I'm guessing if you could talk a little bit more about how we might start to model that interaction component, how we might, build in planning capabilities or other kinds of things into these models that will, which I think will be ultimately required for this generative UI vision that you're talking about.
I think your first question is about how, like, it is true, like all the examples I showed was mostly on understanding and reasoning about the physical world and trying to kind of use one model which can reason about large number of spaces and figure out different type of things without retraining. That's kind of like an initial focus. And I completely agree that what is missing is multimodal output. But I think we have like Mid-Journey guy, the host talking to this morning. I think this is for me kind of like missing piece, right? What would be generative output part of this future AI model, which generate the output to the user and create sort of like a loop from the input to the output and back to the input, right? So I think the generative piece is very, very interesting as an output. And but also it includes, because the interesting things, I didn't show some of the videos. There is a couple of demos we have where the model generate code at the request of draw the graph or something, or draw me a picture, generate the code from the data and then pull out piece of data you want to have. Like we can do search from images, from video. It can pull out the piece of video we want, but it doesn't do by searching the video. It generates the code to pull out this video. Or it can generate the code to draw the graph and visualize what you have in real time. So these, I think, they're kind of really, really horrible right now, so I was embarrassed to show them. But I think this kind of post shows the directions where I think you were saying about is that trying to build really multimodal outputs as well as multimodal inputs. So for closing the loop. In terms of the planning and prediction and recommendation, that's also a very important thing, which also comes up quite often. So, okay, so you know the fridge is broken. Can you recommend course of action? How you'd plan this course of action? I think this is a little bit easier, to be honest, because usually you have in narrow use cases, for example, some maintenance use cases, people have a very clear set of guidelines what to do in certain things. Once the problem is diagnosed, it's sort of you can they actually model, there is existing models here that do really, really well. So I think this is simple planning is definitely I think very natural step forward. More complex planning kind of we create this kind of loop, maybe more difficult.
Sure.
Welcome.
Hi, my name is Jonathan Sutter. So as we were saying before, I run a nonprofit on the side, which is the largest corpus of information associated with the intersection between aviation and autism to help the autism community travel. Here's my question for you. I think there are two contexts. I understand we're not at NeurIPS, we're at UIST, and this question may be better placed at a NeurIPS kind of conference, but two potential applications that don't necessarily have to do with UI that I was just thinking whether you had applied. Number one, based on your prior time at Google, thinking about AlphaFold and maybe, sorry to say this, metagenomic atlas and the like Dr. Krishnan's research out of University of Colorado, proximity really affects, what you're looking at in terms of proximity and context really affects the gene research and the protein structures, like what's near what. Have you considered with the proximity and other like classification and context and again, that proximity focus, applying that to gene research and sort of that AlphaFold. And then the other thing is, have you ever considered with the proximity an API into LinkedIn, because those that are around you could be informed by your network?
I did not consider the protein folding. It's just not my area of expertise, so sorry I cannot. There's a lot of people working on this though, and this is very, very active area of research using generative AI to figure out like new proteins and discover new combinations of proteins. This is very specialized, very, very important area of work.
The API into LinkedIn. Do you think there's any, like in terms of your network and assessing who is around you and context and that kind of thing, like that kind of information informing what you're trying to produce for that? Who is in your network and who could potentially inform the results that you have on the screen? I don't know, maybe it's a bad idea.
Yeah, I think that's one of the use cases probably can be solved. But I think that's can be solved with general ML and even very general techniques. You don't need to general ML. Thank you.
We're just going to add a small appendix to the rule about questions. So no follow-ups. It's going to be a one-shot attempt, and Ivan gets the last word. Because we want to get to Bangkok.
Okay.
Kristen Williams, Emory University. So I have a sort of two-pronged question, super naive. First part is, like, who benefits for this? So as I understood it, you motivated this vision by talking about how, like, detecting the context of the physical world is really hard. And so you're asking us to think about what if we don't do that? And so the second part of the question is, like, maybe how should I be thinking about the role of this vision? Is this meant to be a thought experiment the same way like infinity works as a way to like pull out certain proofs? Help me understand here.
Can we, because this door is very loud outside, so can you repeat the first story? Who benefits
from this vision? Or maybe, so the two-pronged question is, who benefits from this vision? And if that's not a relevant question to ask, what role should this vision be having in our thinking?
Who benefits from this vision? I think who benefits from this vision from building this kind of generative UI is probably users at the end, people who use technology. Because I've spent probably decades, like it is one of the people who benefits, the basic users. We spent decades trying to build interactive system for the real products, and it's extremely expensive and extremely difficult problem, because designing good interfaces. It's a very manual process, as I mentioned. It's a very craftsmanship process. Resources are very, very little. So usually the result of that is that the interaction techniques and interaction research, which happen in this community, really rarely make it to the products because it's just really, really hard to build those interfaces. So anything, any tools which can speed up development interfaces, but keeping the quality, I think is very, very important for the community, and for the products people build, so the customers and regular people using devices becoming better, more aware, more understandable, providing more intuitive interfaces, being aware of your context, providing information when you need it, when you need it, but also giving new opportunities where you don't need to go through the gigantic menus and figure out where you go in the interface, but being able to provide information on the spot. And it's applies both to customers, consumer products, people who buy products on regular devices like mobile phone, but particularly it applies to people who actually trying to build services and businesses and manufacturing and industry. They are really suffering with a huge amount of data coming in, massive amount of data being collected, which they're not able to process. So any way to automate this work and extract meaning from this real-time sensing data and generate it back in a way which is comprehensible, very valuable. It's a huge business. So this is where that's the benefit is, I believe. I don't have any proof though, but it's going to be there.
My question is simple. So one classic popular vision is ultimate interface is no interface, invisible. So interface is bad thing, there should be no interface. What's the relationship between this no interface or your ultimate interface? Your vision sounds like still assumes some existence of interface. What's the relationship between?
I don't believe there should be no interface. I think that this vision of the interface, the best interface, no interface, is not going to work. I think human evolved by using tools, and it's almost part of our DNA, I think, using tools and physical manipulation, doing things. There is a lot of work which shows that using hand and gestures helps you think, and the other way around. It's just part of our thing.
Thank you.
So, yeah, okay. That's the answer, I guess. I answered the question, right? Okay, I'm going to be short then.
From Stanford. So we often build tools to enable and empower people, but often we find that when we do build tools, it actually transfers power from one party to another party. For example, stable diffusion models, it enables novices to create artwork, but potentially at the cost of experienced artists who the model's trained off of. And currently, we as designers, we bake in sort of and arbitrate these types of power transfers, either through regulatory processes or just, as designers within our own practices. So I'm thinking if in this ultimate model, if you remove the designer from sort of the picture, how do you imagine sort of, these decisions to be made when, empowering one group or one party's intentions might conflict with another party's intentions?
I didn't think that far. That's probably version 2 of this talk or something. But I have a general thought is that actually people are really bad in decision making. Self-driving cars demonstrated, right? So the actually self-driving cars are more safer and better than cars driven by humans. So I think we're just afraid, I think there's a sort of resistance to that right now, right? But in narrow industries, like airplane industries, right, pilots don't fly planes anymore. It's all automatic, right? So it's in almost every accident which happens recently in air industry happens because people trying to control the plane, right? So I think my hope is that actually AI will be able to do better decisions than humans in most of these cases, because we'll be able to take into account more factors to making those decisions. The final decisions, obviously, is going to be somebody as a human making certain decisions at the final end, but they'll be given way more detailed and more comprehensive information. That's how I see it in the future.
I see. Thank you.
Hi. Thanks for a great talk. So this is Chen from UCSC. So my biggest question is, how do you think about the challenges caused by the uncertainties of the inference output of these AI foundation models while using it for generating interface design? And I think this can also pose great opportunities for HCI and interface design research. So sometimes this kind of uncertainty is great, right? For example, in our previous research, we actually found designer likes this kind of unexpected output with combinations to inspire their thoughts. But sometimes this kind of uncertainty is not, right? So for example, if they already have some expectation in their mindset, and this might be a bad thing. In fact, some of my friends call this as kind of dark magic, right? Mm-hmm. So I was just wondering, how do you think about this as challenges and future opportunities for, general HCI and interface design research? Thank you.
I think again, so I don't really have a general answer for that. So kind of initial intuition for how things need to be done. I think uncertainty means choice, right? Certainty means a single choice. Uncertainty means choice, right? And I think that for a large variety of interfaces, a large variety of use cases, the end consumer, end user would like to have a choice. So uncertainty has to be there to provide a variety of choices for the user to make final decisions. I don't believe into and this is just based on my belief, right? It's all just an opinion, right? I don't have any proof for that. I don't believe that they're going to be fully automatic, because if you don't have any uncertainty and if you don't provide the choice to the consumer, the customer or people, then you end up basically with a fully automated system, right? That's a complete autonomy, right? Where the system just does what needs to be done, right? That's not interface anymore. That is something. It's robotics. It's automated system. It's something else. It's completely different kind of products or services that we're talking about. Interaction necessarily means feedback, and feedback necessarily means the user given some choice between certain set, right? So I think uncertainty is going to be always part of it. That's my personal opinion.
Thank you.
Right, maybe I'm the last one. Benko from Meta. Okay, Alex. Anyway, great talk, Ivan. I'm actually particularly curious about one statement that you made in your presentation, which is that we need to move from deterministic to non-deterministic in reasoning. And I've been thinking about this quite a lot as well, but I think fundamentally what I struggle with is, I think deterministic interfaces are what allows us to achieve mastery, because we can practice and we know the expectations and we can acquire skill. And actually, the interface becomes not part of our conscious, but moves into subconscious. We drive the car, we can think about carrying conversation, but it's because it's deterministic. We know what's going to happen, we know what the reaction is going to be. So I'm actually curious to hear your thoughts. How do you account for this mastery in the interface if you take deterministic things out of the interface? If it becomes non-deterministic, how do you actually how do we scaffold the user such that they can achieve mastery, that they can become better themselves? Kind of following your thought on tools as what makes us super powerful.
It's more I think, comes down to a philosophical question, right?
Of course.
And more general question. There are two ways to look at this, right? One way to look at this, if you can achieve mastery in something, that means you are good at few things. So the interface, by definition, is simple, right? And the better you are in something, the simpler the interface. In a sense, for example, musical instrument is a good example. The interface of a musical instrument is extremely simple, right? It's not complex at all. And very easy to understand, very easy to learn, very difficult to master, right? But you can master this interface. But it's very serious. So in this case, you don't need AI. It's completely, you have a complete match between human and interface. I think we are coming to the world right now where there is a amount of information, an amount of kind of instrumentation of of the environment with data and use case after use case after use case is too high for people to even to understand this complexity. And I think we're coming to the age that a certain amount of interfaces, you cannot achieve mastery. I think, again, this is my philosophical belief. It becomes impossible to become good at something. And from that perspective, this interface is already non-deterministic because user doesn't know what to do. And doesn't know. So they learn a really small set of skills and stick to that. Not because they're mastery, but because that's what can learn. So can we build interfaces which adapt to the user in the same way humans learn to adapt to each other, right? If you share the common set of cultural beliefs and a common set of kind of like behaviors, which is you learn as like since small age and learn how to behave in society, what to do, what's right, what's not right. We don't need deterministic outcomes to become good in dealing with each other, theoretically. So, can we apply the same techniques to the AI, right? So this is kind of like high-level philosophical question.
Thank you.
Cool. Thank you, everyone. Amazing set of questions. We made it to Benko. Thank you, Ivan, for sparking controversy and debate. We have a demo session that starts at 7. If you would like to talk to Ivan, which I encourage, please escort him to the demo session and continue having these conversations today and tomorrow. And looking forward to seeing you for the other talk tomorrow that Dr. Morris will present on AGI is coming, is HCI ready? Thank you.